So for the open circuit, the graphical velocity analysis with the help of using instant centers have been already calculated. So now for the cross circuit, the technique will be explained. So in a similar manner, we can just, for example, copy this closed circuit. So just simply click here, this select crank, select the crank, and after that press Ctrl button from keyboard and orderly as select other links like this coupler connecting rod, and in this sorry, here we can deselect it. We can include this link. So as we can observe, this crank, this ground, and this rocker and this coupler link AB dash and this rocker have been selected. Now just for example, we can copy them and we can paste onto separate page here like this, and after that we can just move them down or up using right, left, or up down arrows. At any suitable location where the instant centers can be calculated at sufficient space and they do not interfere with any other text or diagrams. So the diagram is quite clear and the method is obvious. So that is why I am moving. So again we can use right arrow so here approximately at the center location. Now we can just move some labels from here, like for example this theta 4, just copy it here and just paste it here, and because the crank angle is same, and after that necessary labels only will be copied from the original diagrams. As we can observe, this theta 4 2 complete, that can be pasted here like this, and we can again move up and down arrows like this. Here like this. So again, for example, from the original diagram we can move this angle as well as this horizontal reference. For example, this arc symbol as well. So just copy them simultaneously and just paste them here, and exactly in a similar manner just use right and down arrows simultaneously or turn by turn. Sorry, the angle actually that I have mistakenly copied is for the open circuit, but we are actually required the angle for the closed circuit, so that can be changed later, no issue. So here like this, and after that, or we can either just or we can just copy the original angle and plus this arc simultaneously. That will be easier. Here just copy paste it here, the whole. Like this. So in this way, so necessary angles have been calculated. After that, for example, permanent instant centers can also be copied from this diagram here, like this instant center I1 comma 2. So just move it here, and after that instant center I2 comma 3. Just paste it here like this. So this is instant center I comma 2 3 at any suitable location here, and after that just copy an instant center and just a bit change if it is creating problem, no issue. So just move it here. This is actually the point B, and this is actually connecting the link number 3rd and 4th. So this is I3 and 4. So again in a similar manner, this instant center is actually I1 comma 4. So in this way the angles have been calculated. Also this horizontal reference can also be copied. Here like this. So here necessary or permanent centers have been shown. So permanent instant centers have been relocated in this manner. I 1 comma 2, 2 comma 3 and 1 comma 4. So the line graph is same here because there are 4 links, and the line graph will be shown exactly like this. So in a similar manner you can use the triangles or trios 1 2 3 and 1 3 4 or 1 4 3 and other triangles. So I will just be elaborating that. For example, if we use the triangle 1 2 3, so as we can observe that the instant centers 1 comma 2 and 2 comma 3, the third instant center I1 comma 3 will be located on the line that is connecting the instant centers I1 comma 2 and 2 comma 3. Means this is I1 comma 2 and this is I2 comma 3. So in a similar manner, yes, this line can be copied from here, I1 comma 2 and 2 comma 3 line, and in a similar manner that can be pasted out here, and after that at the same angle that can just be copy pasted here, exactly overlapping as much as possible. So and The third instance center I1 comma 3 will be located on this line, and now again use the other trio 1 4 3 or 1 3 4. So 1 comma 4 and 3 comma 4. So here we can observe 1 comma 4 and 1 3 4 comma 4. So the other instant center. So just for example copy this line and just paste it here, and then relocate it, change it a bit and make it collinear and exactly overlapping. Here like this. So in this way, so that means instant center 1 comma 4 and 1 comma 3 1 subscript 3 comma 4 from this line graph. Instant center 1 comma 3 will also be located on the line connecting those two lines, and here at the intersection. So in a similar manner, just for example copy this symbol as well. So paste it here, and again just copy this label as well because the label is same here. So now just I will be copy pasting the same data here. Sorry. So with the help of a rotator, now first of all measure the angles in the triangle AB I comma 3. So just copy the labels from here. That is actually point A, and this is point B dash. So So the so here A, I 3 and B dash in the triangle. So we will be determining the sides and angles in a similar manner. So here we can change them, that we actually now require this angle. So in a similar manner, for example, just make an imaginary reference here. Here like this, and as we can observe that this smaller angle as shown in blue color, and here if sorry, if we can just copy and paste it here and just a bit rotate it and again paste it here, that these two angles will be the alternate angle, this angle and this angle. So this angle, these angles will be equal, and as we can, for example, just copy this label and paste it here and just move it here. As we can observe, this angle will actually be equal to 262 minus 180 is equal to 262 minus 1, because this is 180 degree and here up to here it is 262 degrees. So as we can observe, 262 minus 180, so this comes out to be 20 degrees. So here we can observe here that this is 82 degrees. So this angle is 282 degrees. So Now we will be actually calculating this angle. So this angle can also be well calculated. Just if for example we can this angle was actually unrequired unfortunately, so we can just delete it. This angle is not required, so just move this reference here. So here we can observe that I will just be making you understand that this angle here between this horizontal line and this connecting this coupler link, this angle will be equal to this angle, and again as we can observe here. So I will be writing here the angle. Just copy, for example, paste it here, this label. Here that this angle will actually be equal to as we can observe that this angle will be 360 minus 299, which will be equal to 360 minus 299, which is equal to 61 degrees. So we can write here 61 degrees, just angle between this horizontal line and this. So the same angle 60 degree that can be just copied and pasted here. So just copy and paste it here and move it here like this. So after that we can also observe that instead of this angle, the angle here at this location, as we can observe, this angle and this total angle, these are actually the corresponding angles, and this angle which I can show here with the help of just by drawing this arrow, that this angle will be equal to 180 degree minus this angle, and this angle is already have been as we can observe that the already angle that we had calculated here, the angle between this horizontal line and this rocker line, that was actually 262 minus 180 degrees. So 262 minus 180 degrees, and that came out to be 82 degrees. So that means this angle will also be equal to 82 2 degrees. So that means here the total angle here up to here, that will also be equal to this angle. So this angle is 61 degree. So the net angle that we can just paste it here, for example, again move it here like this. Here like this. That this angle will be equal to this 82 degrees angle, this 82 degrees angle that can simply be moved here. And to simplify the diagram, just this 82 degrees and this is also equal to 82 degrees. So this angle will be 82 minus 61, because this angle and these are two angles are same. Sorry, here mistake have been, no, that is sorry, this angle 82 is wrong here. That angle is actually this angle, and the above angle will be 182 minus 82 degrees. So 180 minus 82 degrees, that is equal to 98 degrees. So that means just copy and paste this label and move it here and change it here, that this is equal to 98 degrees in this way. So that means this angle is also equal to this angle 98 degrees. So this angle will be equal to 98 minus 61. So 98 minus 61, so this comes out to be 37. So that means this angle, if we can just copy the label here, paste it here, that this angle will be equal to 37 degrees. 37 degrees. So this angle has been calculated, and after that this angle is same as theta 2, that was 40 degree. So 40 plus this 61 degrees. So this total angle between this AI1 comma 3 and AB dash line will be calculated. So just for example, use this arc symbol with the just to represent the angle. Here like this. Here like this. So that angle will be shown with the help of this arrow, for example like this. Like this, that angle will be equal to that. Just copy and paste this label. Sorry, yes. So that is equal to, this is 40 plus 61 degrees, because here is 61 degrees and this is 40 degree, same alternate angles. So that will be equal to 101 degrees. So in this manner. So once this angle 101 and 37 have been calculated, this third angle can just be calculated by subtracting the sum of these two angles. So 180 minus 101 minus 37. So this angle comes out to be 42 degrees. So just for example use this or symbol here. Sorry, or just we can rotate it here like this. Here like this, and now just paste some label here, copy paste, sorry. So this is equal to 42 degree. So in this way complete angles have been found in this triangle A 1,3 B dash. Now the task is to calculate their length. So in a similar manner use this law of sines. So just copy it from here and just paste it here. Angle at I 1,3 have just been calculated to be 42 degrees. So with the help of law of sines we can observe that the angle between AI1 comma 3 will be equal to sine of 37, which is equal to sine of angle B dash, for example here like this. And in a similar manner, the angle between B dash I13 will be the sine of the angle A, and in similar manner I13. So using this technique, use calculate the side lengths. So analytically, the side lengths that can be calculated here. So I can just copy paste here and label, and then modify the values. So the values that can be calculated with the help of with the help of calculator. So I can just show the calculation. I can just calculate and input the values here, or write the values here. So a I1 comma 3 will be equal to B I1 comma 3 multiplied by sine of beta dash divided by sine of at angle 8A. So I am calculating the value, and once it has been calculated, that I will be mentioning. So before calculating the sorry so as AB is equal to 120 multiplied by sine of beta, and beta is equally angle at B, which is 37 degrees. 37 sine of 37, and divide, that comes out to be 72.21, and sorry, we will be multiplying 120 with the sine of beta dash, so that is 37 sine, and that comes out to be 72.21, and that will be divided the sine of the angle at I1 comma 3, so that is 42 degree. So the 40 that will be divided out, so this comes out to be 107.93 approximately. So AI13, here it comes 107.93 millimeter. So in a similar manner, BI13 can also be calculated 120 multiplied by sine of the angle at A. So the sine of the angle at A is actually 101, so the multiplied by 101, its sine 117.79, and now divided by sine of angle that is actually 42 degrees, so divided by sine of 42 degrees. Sorry, once again, we calculating this bi1 comma 3, that 120 will be multiplied by sine of the angle at A, which is 101 sine, so that is 117, and that will be divided out by 42 degree sine, that is 176.042. so this length b dash I3, that actually results in 176.042. these are analytical values. Now we can calculate the graphical results, compare for the purpose of comparison. So move the, for example, this scale here, and in a similar manner just reorient it, and so here we can observe that this angle, this scale is showing 5.12, for example. So we can just copy this line and paste it there. So here as we can observe that AI13, that is equal to here 5.2, as we can observe 5 multiplied by 20, so 5.2 multiplied by 20, this comes out to be 104 millimeter. So this be 104 millimeter, and our analytical results are trigonometry 107.93, so that is quite much near. So only 3 or 4 millimeter difference is there, so that is all okay. So in a similar manner, now calculate, now measure this total, sorry, move it from here, because actually this is B dash point from here up to this I13. So the approximate value that can be shown here, that is 8.5, 8.6, 8.7, 8.8, for example. So here 8.8 for example. So just multiplied by 8.8 multiplied by 20, so this comes out to be 176, and our result R is exactly equal to 176. So that means our results are 100% correct. So in this manner VI13 has been calculated. So in this way, now the procedure is quite simple, that again now find the angular velocities and similar manner. So just copy paste this data here and just modify it just to save time. Here the omega 3 will be equal to VA divided by AI13, and that is actually the same here, as we can observe that here AI13, so change it here. So here in our case this is equal to 104. So the result that 1000 divided by 104, so this result is 9.61 radian. So in this case the angular velocity of the cross circuit coupler is 9.61 degrees, 61 radian, 9.61 radians per second, and the VB according to scale that will be equal to 9.61 multiplied by BI13, and BI13 here is 176, so type it here 176, and that comes out to be 961 multiplied by 176, so that comes out to be 1692 millimeter. So that is equal to 1692.3 millimeter per second approximately. So now the omega 4 in the case of closed circuit, that will be equal to the magnitude of VB and divided by O4A. So just copy and paste this value here, and O4A, and this result just divide it by 80 millimeter. So this comes out to be 21.15 radian per second. So omega 4 is 21.15 radian per second. So in this way, now we can show just the labels of the orientations and magnitudes. Magnitudes have been calculated. Just show the orientations, like for example this was the direction of the velocity vector V A, that was actually perpendicular and at this point. So just for example calculate its label. Here, so this is VA, so that means because it is still, as we can observe, that the direction of rotation of this coupler link AB dash is again in the clockwise orientation. So the velocity of point B here, that will be actually here at this location and exactly perpendicular to this line. So this is actually VB that can be copied from here and that can be pasted here. So this is equal to VB. So as we can observe that the direction of rocker rotation will be in the clockwise orientation in this case, so that will be negative. Also the direction of rotation of the connecting rod is also in the negative orientation. So in this way the velocities have been calculated. Now as a further step, if we want to require the relative velocity of VB dash relative to A, for example, so we will be writing the velocity vector equation. For example, VB dash subscript A in this manner, and just that will be equal to the velocity of point A plus here that the velocity of VB. So this is the correct velocity vector equation, that VB will be equal to VA plus VB dash. We can type it here VB dash because for the that is for the cross circuit. So in this manner, so this is the velocity vector equation. So as we can observe that VA and VB dash have been calculated, so VB dash A can be simply calculated using the velocity vector triangle. So that we can create the velocity triangle according to scale. For example, we can use the velocity scale here. For example, we can say, as we can observe, that the magnitude of the velocity of the velocity of point is 1000 millimeter. So the scale, any suitable scale can be selected. For example, we can say that the scale is, for example, 400 millimeter per second is equal to 1 centimeter. So this will be implying that that will be implying that VA according to scale will be equal to 1000 divided by 400. So this will be equal to 1000 divided by 400, which will be equal to 2.5. so that means that is equal to 2.5 centimeter. In a similar manner, as we can observe that VB dash is 1692, so that can also be calculated here, that copy and paste. So equal to divided by 400, and this is equal to 1690 2 point 1692.3 divided by 400, so this comes out to be 4.23, so approximately 4.2 centimeter. So after that, it important is that their orientation must also be known according to scale. So here it is 40 millimeter, so that means the velocity is perpendicular, so that means this alternate angle will be 40, so the VA angle will along the horizontal will be 50 degrees. And in a similar manner, we will also be requiring to determine the angle of this VB with the horizontal or vertical. So as we can observe that VB is perpendicular to link this rocker link, so we will have to determine the angle. So that angle with the help of or we can measure with the help of protractor, or we can use some trigonometry. So at this stage, because angle at moment I am trying to calculate, if that can be quickly calculated, then it is good, otherwise the method is clear, so you can try it yourself. So the angle that can be calculated VB with the horizontal, that angle will be equal to, because this VB is perpendicular to this rocker link, so that means that is the angle between VB and the rocker is 90 degree. So as we can observe that the angle of the rocker line with this horizontal is total 98 degree, so we will simply be, so that means that the angle between this horizontal and this rocker line is also 98 degree. That angle is shown here. So we will be subtracting 90 degree from 98 degrees, so the angle of VB with the horizontal will be 9 degree approximately. So that means, for example, if I can just copy this label and just move it from here, so that means this angle will be exactly 9 degree approximately, in this way. Just so the angle of the VB with the horizontal will be 9 degrees. So at correct angles, now I can, just to make you understand, can draw the velocity triangle and then can measure according to scale or trigonometrically. So first of all, according to scale, draw for example, uh, here at this location, for example, we can draw this is velocity VA, and if we can use the protractor, just move it from here on to the next page, bring it here, no issue. So here, as we can observe, we are to make it 50 degree at, and again, sorry, we can move this scale out here, just move it here. So here first of all, make this line at correct angle. So here, as we can observe, that this is 180 degree line, so this angle is to be 50 degrees with the horizontal, because this is crank is at 42 degrees, so alternate angle of the crank will be 40 degrees, so total is 90, so 90 minus 40, that the angle of VA with the horizontal will be 50 degrees. So in this manner, this is 10, 20, 30, 40, and here, as we can observe, that this is equal to 50 degrees. So now place the scale parallel to it like this. So now we can move it, and here, for example, we can just approximate. So like this, as we can observe, the crank length according to scale is the velocity according to scale is 2.5. so here this is 1 centimeter, this is 2, and here is just 2.5. so uh, so here this is nearly equal to 2.5. so in this way VA vector has been drawn. Now move the protractor out. So in VA, as we can observe, that from this equation, actually implies that VB dash will be equal to vb dash equal to vb dash minus va vectorially. So that means that vb dash will be equal to the velocity difference of velocity of vector vb dash minus the velocity of vector va. So va has been drawn, and as we can observe that the negative of the velocity vector va will be added to the velocity of vector vb dash. So uh, for example, uh, we can draw the vb dash vector. For example, just or draw an independent line here. For example, at this location vb is 9 degree along the horizontal. So for example, just place the protractor here at this location here, and for example move it here, and this is here 180 degree line. So this is approximately as we can observe that this is approximately equal to 9 degrees. So here, so after that, according to scale, this length is 4.2 centimeter. So move this scale parallel to that line here, approximately, and now measure as we can observe here 1 2 3 4 and here 4.2. so move it here. So this is approximately, we can say, 4.2 centimeter here. 1 1 2 3 4 4.2 centimeter in this manner. And now this equation states that will be the velocity difference. That means in vb dash the negative of the velocity vector va will be added. So the negative of the velocity vector that will be same equal to that we will be reversing its orientation. So its orientation can simply be reversed here like this. For example, go into shape format area and here go into the flip option, and at a moment first is flip this along vertical, and once again flip this about horizontal like this. So as we can observe that has been flipped at the same angle. So in this way. So now move this protector out, and as we can observe that the negative that will be added vectorially into vb dash a, and that will actually be giving the resultant vb dash a. So this will be vectorially added, the negative into it, and so the relative velocity vb dash a, that will be actually started from here to here. So this velocity vector is actually vb dash a. So just copy any label from here and paste it here. So just change it that this is velocity v b dash a. This is velocity va, means actually this is the negative or negative of velocity va that has been added, and this is the velocity vb. Copy and paste, sorry, this label, or just simply copy this label and paste it here and just move it here. So this is equal to v subscript b in this manner. So as it is clear from the diagram that if we, for example, move this VBA, just copy it and, for example, paste it here in the original linkage and just move it here, and as we can observe here that this will actually be the location of the VB-A. So I can again copy this label and paste it there, move it there, here. So as we can observe that this VB dash is exactly perpendicular on this link, so that means our diagram is quite clear. And after that we will only be measuring this length of this vector according to scale. So for example, just move this scale here, sorry, at this approximately we keep it exactly parallel to the velocity vector line, but I am just approximating just to make you understand. Here as we can observe that the value is approximately 1 2, and here approximately we can say that it is equal to somewhat 2.9. for example, according to scale according to scale. If we can just copy this line and just modify here that v b dash a, that will be equal to according to scale, that was 2.9 centimeter, and our scale that was equal to 400 millimeter, equal to 1 centimeter. So multiply it by 400 millimeter. So as we can observe that 2.9 multiplied by 400, which is equal to 1160. So that means the velocity that is approximately equal to 1160 millimeter per second. So in this way. So another way, we can simply use law of sines at this triangle. So you can verify the results. So if you find any discrepancy, you can let me know. You can make the trigonometric calculation on this triangle or angles yourself. Just to make the video shorter, I am finishing the video here. So thank you and assalamu alaikum. If you have any question, you can fairly ask positively, and always kindly be careful. If you comment, always comment positively. Never try to depreciate me in any way. So all these videos are uploaded, are made just to help you and assist you, and as a God wills, and my contribution toward the society. So this is my first preference. So this is what I can contribute. So kindly always, either you don't comment at all, but if you have a real confusion about any concept, you can positively, with a goodwill, you can comment. And once again, thank you and assalamu alaikum. Jazakallah.